Jake and Samson finally put aside their differences to start drilling the brackets. They decide to mount them vertically based on what they learned from Mike's structural test.
This plate's going to hold our pulley, and that's going to be what supports our whole contraption from going up and down. So the reason we're going vertical instead of horizontal is if we're pulling right here, and this is against the wall, if it's vertical, not only does it have to pull the top out, but it has to push the bottom in at the same time. It has to pivot right here. When it's horizontal, it doesn't have that much to do. You know what I mean? It can pull out because the bottom's right here.
Please. I'm glad we're going vertical. I think it's going to be stronger, definitely.
While the team heads inside for more supplies, Mike's crew uses the scissor lift to take measurements for his scooter-saving solution.
We're measuring where we're going to put our saddle points. It's going to hang this box out over the edge of the wall. When the scooter comes crashing into it, knocks it off, slides down that guide wire to safety. It's a really simple plan. It's going to be awesome.
Now we're getting our secondary chute put out, so this is going to be the inside chute. Tucking this over the inner rail, and then comes back out around the outer rail, and then we'll clamp it. So you have a little extra strength as it's pulling in on this particular rail. And the outer chute is also secured with the tie lines and the risers. So all that is just giving us additional levels of protection to hold on to this thing.
Dun, 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 dun.
With both parachutes securely attached, the team moves their scooter net outside.
Right there, put it down. Go through the bottom.
Samson and Pete begin assembling the scooter net's counterweight system.
A counterweight system is basically a way to balance a force on one side of a lever with a counterweight on the other side. The solution that the builders have basically has a gigantic 15-foot lever that reaches off to the top of the roof. As the scooter enters this net, the lever pulls forward and the counterweight rises. That balancing stops the downward motion. Right now, the most important thing for these challengers is to figure out that precise amount of weight they need as their counterweight. Too little, this net comes swinging down and crashes into the ground. Too great, the net doesn't move at all. The scooter either tears through it or it just crashes right into it and breaks itself just from the G-forces of that shock alone. And right now, it doesn't seem like they realize the actual importance of calculating how much weight they need to put on that.